Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning deadlock in distributed systems. Let us see the concept of deadlock. So let us consider a scenario wherein there are two characters, Mrs. Iyer and Mr. John. Mrs. Iyer is asking, hey, why are these cars not moving? So if you look at this picture, the cars are stuck into a traffic and she's a bit confused. Why are these cars not moving? Mr. John replies, because the cars are in deadlock condition. And Mrs. Iyer says, what is deadlock? So he replies saying that a set of processes is said to be in a deadlock when every process in the set waits for an event that can only be caused by another process in the set. So here, just map this definition to the diagram over here or the picture over here. Let us consider this car. This car cannot move backwards, not even frontwards, because it has been blocked by some other cars. Similarly, this car is also not able to move in backward or front direction because it has been blocked by some other cars. So it is the case with all other cars in the image. So this is where the deadlock comes into picture. Now, how to map this concept with the processes and resources in distributed systems? Let us see that. Before that, this Mrs. Iyer and Mr. John are working on, let's say, one database. There are two tables, A and B. Mrs. Iyer is working on table A and Mr. John is working on table B. Now, both want to update the set of two tables that are related. A and B are related and both want to use A and B simultaneously. But then there is a problem. What is the problem? Because both are trying to access the resource simultaneously. Both want to access the resource simultaneously. So while Mrs. Iyer is updating table A, the table is locked, so no other transaction can access it. So even if Mr. John wants to access table A, it has already been locked by Mrs. Iyer and table A will not be available for Mr. John to update. Similar manner, at the exact time, table B is locked as Mr. John is updating it. And Mrs. Iyer finds that table B has been locked because it has been already, because Mr. John is already using it. And Mrs. Iyer has to wait for table to be released. At the same time again, Mr. John wants to use table A, which has already been with Mrs. Iyer. And he finds that table A is locked. And so he also has to wait for some time. Now in this waiting period, Mrs. Iyer also gets irritated and Mr. John also gets irritated. So both of them cannot continue with the transaction and this condition is called deadlock. Why? Because Iyer is keeping on waiting for B to release and Mr. John is keeping on waiting for A to release. Both of them will not be releasing and this condition may lead to a deadlock. So let us map this concept to our distributed systems. Process P1 requires a resource 1 and resource 2 for completion of its execution, but then this resource 2 is already allocated to process P2. So here P1 goes in waiting state. Then process P2 requires resource 2 and resource 1 for its completion, but then resource 1 is with process P1. So P2 also goes in waiting state. And both the processes will wait for each other till infinity. Now these are the two processes and two resources. Resource 1 is assigned to process P1 and process P1 is requesting resource 2. Similarly, resource 2 is assigned to process P2 and it is requesting R1, which is held by P1. That is process P1. And this is where a deadlock condition takes place because both the processes are waiting for the resources that have been allocated to other processes. So let us consider this example. This is where T1, T2, T3, T4 are the cars, we can say, and B1 and B2 are the junction points. So if you just consider this T2 and T3, T2 is moving in this direction and T3 is moving in this direction. At some point of time, both the cars will come in front of each other, and unless and until one move backwards, the other cannot go in forward direction. So here the cars are the processes and the junction points are the resources. One more example is that there are two friends, one is having a spoon, one is having a fork. Unless and until both of them have fork and spoon both, they cannot have their lunch. So one friend is saying I need a fork to it, which is already with some other friend, and this friend is saying that I need a spoon to it, and which is already with this friend. So unless and until one of the friend releases its spoon or fork, the other cannot have their dinner or lunch. So here Mrs. Iyer is very confused and she says, how to know that the processes are deadlocked? So Mr. John says, yes, there is some characterization for a deadlock to occur. There are some conditions for a deadlock to occur. So let us see which are the conditions for a deadlock to occur. So basically there are 4 conditions that for a deadlock to occur, and this should hold simultaneously. First one is mutual exclusion, followed by hold and wait, then comes no preemption, and then comes circular wait. We will all see these conditions in detail. So for a deadlock to occur, if all the conditions are true, then a deadlock will occur in the system. If we are successful in avoiding at least one of the condition, then deadlock will not occur. Now let us see this mutual exclusion. What is mutual exclusion? So resources are shareable resources as well as non-shareable resources. Shareable resources means multiple processes can access at the same time. So shareable resources here can be file which can be accessed by multiple processes at the same time. Non-shareable resources here, the example would be printer. That means only one process can access at the same time. So that means if a particular process is printing a document, then if the second process wants to print a document, then that particular document will go into its queue and it will keep on waiting until and unless the first process releases it. So here only one process at a time can use a resource. So these resources are non-shareable. So if they are non-shareable, so here it is mutual exclusion. That means only one process is using that particular resource at one time. This is mutual exclusion. Then comes no preemption. A resource can be released only voluntarily by the process holding it upon its task completion. So here there are two friends. This friend is using a computer and this friend is asking for the computer. And let us consider this computer as a resource. But then unless and until this friends want to release his computer and make it available for this friend, it cannot be given to this friend. Similarly, that means if a process wants to release that particular resource, then only that resource will be released and given to some another process. So here now this friend says that I have completed my usage of this resource. Now you can take this resource, and the resource will be allocated, or the computer will be allocated to this friend. So here see again, resource 1 is assigned to process P1 and it is waiting or it is requesting for R2 which is already allocated to P2, and P2 is waiting for resource 1 which is allocated to P1. Now here this P2 should not be preempted, or any process should not be preempted or forcefully stopped. It should be voluntarily saying that now I want to release the resource and now some other process can take over it. It cannot be forcefully taken away by some other process. So here P2 says that now I have released the resource, let's say resource 2, and it has completed its execution. Now it will assign the resource 2 to process P1. Now P1 requires two things for completion of execution, that is resource 1 and resource 2. So when resource 1 and resource 2 are available, process P1 completes its execution. Similarly, hold and wait. So here hold and wait is a process holding at least one resource is waiting to acquire additional resources held by other processes. Just look at this example. This friend has two big books and this friend is waiting for the book to be released by this friend. Unless and until this friend releases this book, she will not be able to study. So this friend just lends or just gives this book to this friend, and this friend starts studying. Simple as it is. So a process here is holding at least one resource and it is waiting to acquire additional resource. So see, process P1 is holding this resource, that is at least one resource, and is waiting to acquire the other resource which has been held by some other process. Similarly here, process P2 is holding R2 and it is waiting for R1. So this is hold and wait condition. And the last one is circular wait. So here if you see, there will be a set of processes P0, P1 to Pn which are waiting processes such that P0 is waiting for a resource that is held by P1, P1 is waiting for a resource that is held by P2, Pn minus 1 is waiting for a resource that is held by Pn, and Pn is waiting for the resource that is held by P0. So there is a cycle starting from P0 coming back to P0, and that is called as a circular wait. So these are the deadlock handle strategies: deadlock prevention, deadlock avoidance, deadlock detection, and deadlock recovery. So this is how the deadlocks can be handled. So let us see that in next video. Thank you for watching this video. If you have any doubts, please do post in the comment box. Please like, share and subscribe to the channel. Thank you for watching.